Hello everyone, welcome to OpenCV tutorial with Python. In today's video, I am going to show you how to detect the particular color region and analyzing the pixels value of an image step by step. Okay, so before moving on to the code, I am going to show you that we need to analyze this image named as goat.jpg and detect the red and white region color and just particularly exclude all the other things and only the red and white colored part. And we can also analyze the image pixels, that is the minimum pixel values, maximum pixel values, or you can see that the foreground pixels and background pixels as well. So we are going to analyze the image with this color detection. Okay, so here I am going to create a file named color detection and analyzing image.py. First of all, I am importing OpenCV CV2 and NumPy as well. So yeah, our main task is to implement these two functions that I am writing, that is detect red and white region, and this function is going to take a parameter which is named as image, basically an image, the image that we have stored in the same folder, and I need to implement another function which is named as analyze goat. Okay, so this function is going to take an image array, which is basically a grayscale format that we will be discussing later on, and analyze all the pixel values. Yeah, so before moving on to the code, just to clarify you for your information knowledge, that if we want to detect any particular color region from an image using OpenCV, then we need to convert this image into its HSV form. So what is HSV form? The full form of HSV is hue saturation value. Sorry. So this hue saturation value format is basically uh, applicable for distinguishing different regional colors, and we can easily exclude any particular color part as well. So I'm going to first convert this image into its HSV format, and the function is convert color, and this will take the image as parameter and CV color. So yeah, another part that I need to clear is that when we read an image using OpenCV, then the image is automatically read as the BGR format. Okay, so I need to convert it from BGR to HSV. There you go. Then I need to tell the interpreter that what is the particular region or the standard value of the color red, that is the lower value and the higher value of any color. So in that way, the machine can actually understand, yeah, that this is the red colored part from the whole image and this is the white color part. So you can easily find the values of the lower and upper values from the internet. So for this video and this image particularly, I am going to take the values that I have stored previously, and which is for red lower, the value is 150, 100 and 100, and I need to mention a data type as well. Yeah, you know that in RGB or BGR color format, all the values is actually between 0 to 255. So I think an unsigned integer of bit 8 is okay for storing all the numbers. So yeah, so similarly I am going to declare another variable named red higher, and the values will be changed, and these values are 180, 255 and 255 as well. Similarly, for coming to the white color part, the white lower color will be having the BGR value of 75, 0 and 99, and then again the higher part will be 179, 62 and 255, and the name of the variable will be white hair. Yeah, okay. As I'm done with this part, so let me explain you something before writing the next part of code, that is how the masking happens inside an image. So think about that this is the whole image, and there I have certain particular color white, and I have color red as well. So first of all, what I need to do, I need to mask this red color part and this white color part from this image. Then I am going to combine these two particular masking using bitwise OR operation. Okay, and finally these two combined part, and with the full image I am going to run a bitwise AND operation, and this will give us the value of only this combined masked part of the color region which has red and white color only. Okay, so these are the things that I am going to do here. And firstly I have to red mask, and the function is in range. This will check the lower and higher limit of my color red, and this will take the HSV formatted image for the masking. Red higher, yeah. And for the white mask, basically I am going to just copy this and paste it here, and in this case I have my value white lower and white higher as well. Alright, then finally I am going to combine this red and white. Oops, combine red, white. This naming format is okay. Yeah, and I have to do bitwise OR operation, that is here. You can see bitwise OR, and I have red mask and my white mask part. So we have the combined red and white masked region, and finally I am going to get the final image, which I will operate bitwise and this function is going to, yeah. So one noticeable thing is that in this function I am going to pass the parameter of the image, not the converted HSV form of the image, because I need to mask from the real image, and then I will get the red and white color part. Okay, so my mask is combined red and white. Yeah, so now what I have to do is I have a function which is cv.imshow, and this will actually display our image, and I have to write something for the window, and let's see, I can give this red and white color combined. Yeah, and then the final image. Yeah, so this image will be displayed in our window, and lastly what we have to do is I have to use this function which is wait key. This function what it does is basically that it waits for some time, some period of time, which is calculated in millisecond unit, until I give or press any key function to the window. So giving 0 is uh, equal to that I don't need to wait for any command. So until I close the window, it will be displayed forever. Okay. So yeah, so my detect red and white color regions function is implemented, and for this part I have to calculate the pixel value minimum, which is using np.min and the image array. Okay, so for coming to the image array part, this is actually the converted grayscale image of the main image. So why we need to convert it into a grayscale format? Because I need to analyze only the black and white pixels, or the zeros or non-zeros pixels you can say, or the foreground pixels and the background pixels. So it is easy for us to implement this function in this way. Okay, so the maximum pixel value will be np np.max, which is the same parameter image array. Then the average pixel value, PV average, goes to np dot average. Sorry, we don't have any function named average. We have mean, which will work as the same, and then pixel count. So what I can give is non-zero. Okay, and we will count the pixel non-zero and the same parameter as well. Okay, so coming into the pixel count 0, we don't have any built-in function for counting the zero number of pixels. Okay, or the pixel 0 in real sense. What we have to do is we need to eliminate the pixel count of non-zero value from the total number of pixels that we have in our image. Okay, in that way we can get our 0 pixel count. Okay, so image array dot size, the total number of pixels, minus pixel count non-zero. Okay, so this will do our job. Then I need to display this in our terminal using the that is the minimum and maximum pixel value, and for minimum we have pixel value min, and for maximum we have pixel value max. Okay, then just copying it and paste it here. For minimum and pixel value we have the average pixel value. This will be our PV average, the total number of, we can say that, non-zero and zero pixels. This will be string actually that I forgot. Okay, then the value will be the pixel count non-zero firstly, and then lastly the pixel count of 0. Yeah, so I can see that my function is completed. Both the function is actually completed. So lastly what I need to do, I need to read the image, the initial image, that is I'm going to name it as Messi, and the function is cv.imread, which is actually read the image in the BGR format, and the name of the image is goat.jpg. Okay, that's it. Then I'm going to pass this messy image in the detect red and white region function, and lastly the grayscale messy, or we can say messy gray scale, the converted image. And we have already seen the use of convert color function. So the image is messy and I need to convert it from BGR to, in this case, gray. All right, and finally in our last line of code I am going to pass this image array or the grayscale image in our analyze function, that is messy grayscale. Okay, let's cross check the function. Hmm, I don't see any fault here. Yeah, so let's run, and okay, there you can see only the red and white colored part from this image. And here, if I run this program again, you can see that the minimum and maximum pixel value and all the necessary information is given or displayed in the terminal. As you can see, the minimum number of pixel values is 0 and the maximum is 254. That is our average value, which is almost 70. The total number of non-zero pixel value is near 1 billion and the zero pixel count is 600. Okay, so in this way we can actually detect a particular color region and analyze our image, the pixel values, using OpenCV and Python. Okay, stay tuned. Happy learning.